Good morning. I'm Charlene Lewis.
And I'm Angelica Mago.
And we are SNR, Science News Report.
Let's talk about the Earth's atmosphere. Composition of the atmosphere. A blanket of air gases called the atmosphere protects the Earth. The Earth's atmosphere is a mixture of gases, solids, and liquids that surrounds the planet. The atmosphere is primarily composed of 78% nitrogen, 21% oxygen, and 1% argon. Another important gas, which is the ozone, is a form of oxygen that absorbs most of the ultraviolet radiation that enters the Earth's atmosphere. Ultraviolet radiation can cause skin cancer, genetic mutation, and cataracts. Jet emissions, fallout from nuclear explosions, some fertilizers, and CFC scans destroy ozone molecules. Most countries have banned the use of this product, but scientists believe that much damage have already been done to the atmosphere. The damage is referred to as the ozone hole.
Let's talk about the layers of the atmosphere. A blanket of air, which we call the atmosphere, surrounds the Earth. It reaches over 560 kilometers, 348 miles from the surface of the Earth. So we are only able to see what occurs fairly close to the ground. Early attempts at studying the nature of the atmosphere use clues from the weather, the beautiful multicolored sunsets and sunrises, and the twinkle of the stars. With the use of sensitive instruments from space, we are able to get a better view of the functioning of our atmosphere. The atmosphere, solar energy, and our planet's magnetic field support life on Earth. The atmosphere absorbs the energy from the sun, recycles water and other chemicals, and works with the electrical of magnetic forces to provide a moderate climate. The atmosphere also protects us from high-energy radiation and the frigid vacuum of space. The envelope of gas surrounding the Earth changes from the ground up. 4 distinct layers have been identified using thermal characteristics, temperature changes, chemical composition, movement, and density.
The troposphere starts at the Earth's surface and extends 8 to 14.5 kilometers high, 5 to 9 in miles. This part of the atmosphere is the densest. As you climb higher in this layer, the temperature drops from 17 to negative 50 degrees Celsius. Almost all types of the weather could be found in this region. The tropopause separates the troposphere from the next layer. The tropopause and the troposphere are known as the lower atmosphere.
Stratosphere. The stratosphere starts just above the troposphere and extends to 50 kilometers, 31 miles high. Compared to the troposphere, this part of the atmosphere is dry and less dense. The temperature in this region increases gradually to negative 3 degrees Celsius due to absorption of ultraviolet radiation. The ozone layer, which absorbs and scatters the solar ultraviolet radiation. In this layer, 99% of air is located in the troposphere and stratosphere. The stratopause separates the stratosphere from the next layer.
The mesosphere starts just above the stratosphere and extends to 85 kilometers, 53 miles high. In this region, the temperature again falls as low as negative 93 degrees Celsius as you increase in altitude. The chemicals are in the extended state as they absorb energy from the sun. The mesopause separates the mesosphere from the thermosphere. Scientists call this region as the stratosphere and mesosphere, along with the stratopause and the mesopause, the middle atmosphere.
Ionosphere. The ionosphere is the layer of electrically charged particles that begins between 80 and 85 kilometers above the Earth's surface. Particles of the atmosphere are bombarded by energy from space and forms ions and free electrons. These charged particles are used to communication because at night they reflect radio waves during the day. Radiation reception is terrible over long distances because the waves are absorbed. When streams of particles from solar flares come in contact with the ionosphere, the ions glow different colors. The result of the display is an aurora. Auroras are the brightest near the poles due to the reflection of the particles by the Earth's magnetic field. Particles from solar flares disturb radio, TV, and telephone transmission.
The thermosphere starts just above the mesosphere and extends to 600 kilometers, 372 in miles high. The temperature goes up as you increase in altitude due to the sun's energy. Temperatures in this region can go as high as 1,727 degrees Celsius. Chemical reactions occur much faster here than on the surface of the Earth. This layer is known as the upper atmosphere. The upper and the lower layers of the thermosphere will be studied more closely during the Tethered Satellite Mission, TSS-1R.
And the last is the exosphere. The exosphere begins at the altitude of about 500 to 700 km above Earth and extends out to the interplanetary space. At these altitudes, atoms and ions are very far apart. Some gases in the exosphere actually escape into space. Particles of the solar winds are concentrated into radiation layers at about 3,000 and 16,000 km above the Earth's surface. These layers of the exosphere are the Van Allen belts and are held in place by Earth's magnetic field.
Meanwhile, in heat transfer, energy from the sun moves through space by radiation. Radiation is the transfer of heat energy by means of the electromagnetic waves. A campfire gives off radiant energy in the form of heat and infrared radiation. Conduction is the transfer of heat through matter by actual contact of the molecules. Molecules are always in motion. Heat gained by the atmosphere from radiation and conduction is usually transferred by convection. As air absorbs energy, its molecules move faster and farther apart. This movement decreases the density of the air. Cold, dense air sinks, forcing warm, less dense, or upward. This transfer of heat due to the density differences is called convection. Convection currents cause a constant exchange of cold, dense air for less dense warm air.
Movement of air. Energy from the sun warms the atmosphere, causing currents and ascending and descending air or wind. Winds distribute energy around the Earth's atmosphere. Wind can blow from any direction. Wind is simply moving air. Forces cause the air to move. One type of force that produces motion in air results from difference in air pressure. Pressure gradient forces causes air to move from a region of high pressure to a region of low pressure. Areas of high and low pressure form in the atmosphere as a result of changes in air temperature and density. As soon as the pressure gradient first starts air moving in the atmosphere, the Earth's rotation begins to affect it. Since the Earth rotates, air moving away from the region of high pressure appears to turn toward the right in the northern hemisphere and toward the left in the southern hemisphere. This phenomenon is called the Coriolis effect.
Land and sea breezes are types of local winds. During daylight, the sun heats land more quickly than water. The process of conduction carries heat from the ground to the air above it. As heat air rises, cooler air from the water moves in to replace it. Since winds are named for direction from which they blow, this movement of air is a sea breeze. At night, land cools more quickly than water. The air over the water is now warmer than the air of the land. The warmer air rises and the cooler air moves offshore to take its place. This flow of cool air from land to the water is a land breeze.
News is over.
Hope you learned a lot from it. Again, I'm Charlene Lewis.
And I'm Adredi Camago.
Good day!